3.3, solving systems of equations using the elimination method. Let's go to work. As a reminder, systems of equations is when we solve two or more equations simultaneously, which is a big word that just means at the same time. We've already talked about graphing method and the substitution method. Today, we will talk about the elimination method, aka also known as the addition method. Be honest with you, with the reading and highlighting, I did not like some of the things that were given to us in a book talking about subtraction. I like to consider it the addition method just because that's the way that I learned it. So we talked about the fact that depending on how the system is given to you, one of the three different methods may work better. In this case, looking at number one, the elimination method works best. Why is it called the elimination method? Because we want to eliminate one of the variables. In this particular case, number one, if I look at my two x values, if I were to add those together, that's why I call it the addition method, 9x plus a negative 9x, those would cancel. That's why we call it the addition method. And that's what we're looking for. It also eliminates one of the variables, therefore the elimination method. So I'm going to eliminate those. 9x minus 9x is 0x, but we don't really have to write 0x, do we? So it's gone. Negative 2y plus negative y is a negative 3y. And then 4 plus 2 is 6. Now I have one variable, one step away from solving for that variable. Divide by negative 3, divide by negative 3, and y equals negative 2. I have half of my solution now. I can take that y and plug it into either of my original equations. I'm going to take the bottom one just because I can see there's no coefficient in front of the y. So I have negative 9x minus negative 2 equals 2. So negative 9x plus 4 equals 2. Subtract 4 from both sides. So negative 9x equals a negative 2. Divide by a negative 9. Divide by a negative 9. And x equals 2 ninths. So my solution then is 2 ninths negative 2. I know there's a fraction in there, but that doesn't scare us, and we can handle it just as we did. That is the elimination method. In this case, we eliminated the x's. Let's try it again. Looking at problem number 2. If before we begin, we look at problem number 2, and we can see right away that those y's, if I were to add those together, they would cancel. So that's what I want to do. It's what I'm looking for. I want to eliminate one of the variables through addition. So y minus y cancels, which is beautiful. 7 minus 8y is a negative 1x, and that equals 8. Negative 8 plus 8 is 0. Divide by a negative 1, x equals 0. Now I can plug that into either equation originally. Again, I'll take the top one just because that's the one I choose. So 7 times 0 plus y equals a negative 8. 7 times 0 is 0. 0 plus y equals a negative 8, or y equals a negative 8. And again, my solution is, 0, negative 8. So as you can see, in all three of the different ways we've looked at systems, when they were set up beautifully for that method, it's really easy to simplify and solve. It's when it's not set up beautifully, or you have to manipulate one of the ways or methods that we get into more work and more difficulty. For example, look at number 3. If I look at my y's, nothing cancels there. If I look at my x's, nothing's going to cancel there. So what do? Well, I can look to see it would be nice if I had a negative 12x here. Well, how would I get a negative 12? I could multiply it by a negative 2. Or if I had a negative 7y there, that would be good, and I'd multiply it by a negative 7. Now, I'm going to choose the 2 just because it's a smaller number and an easier multiplication, because I get to choose what I want. Now I'm going to put that answer as red. So negative 2 times 6 is a negative 12x. Negative 2 times y is a negative 2y. Negative 2 times 8 is a negative 16. Now that's one of the areas that a lot of people miss. A lot of people forget that you have to multiply that negative 2 on both sides. It's everything in the equation to get an equivalent one. Now, looking at these two equations, I can now use my addition method or to eliminate my x variables because they will cancel. 7 minus 2 is a 5y. Negative 4 plus a negative 16 is a negative 20. Divide by 5. Y equals a negative 4. Now I have one of my solutions. Now I can plug that into any one of these three equations. Does not matter which one you plug it into. Just for kicks, I'm going to take this second one here and plug that in for y. So I got 12x plus 7 times a negative 4 equals a negative 4. So 12x minus 28 equals a negative 4. I'm going to add 28 to both sides. Oops, ugly. So plus 28 plus 28. So 12x equals 24. Divide by 12. Divide by 12. X equals 2. So my solution is 2, negative 4. In this case, I had to manipulate one of the equations in order to get something to cancel. And that's acceptable. Causes a little bit more work, but no big deal. Looking at number 4. If I look at my x's, I see nothing's going to cancel. If I look at my y's, again, nothing's going to cancel. So I'm going to choose the x's, because if this first x was a 4x, so I can multiply this whole thing by 4 and get what I need to cancel. So let me do that. 4 times x is 4x. 4 times y is 4y. And 4 times 0 is still 0. Now I can use the addition method. My x's will cancel. 6x plus 4x is 10y, or excuse me, 6y plus 4y is 10y. And then negative 20 plus 0 is negative 20. Divide by 10. Divide by 10. Y equals a negative 2. Now, I'm going to choose this original equation because it looks the simplest to plug it in. So I have x plus a negative 2 equals 0. Add 2 to both sides. X equals 2. And there are both parts of my solution, which is 2, negative 2. Again, I had to manipulate one of the equations. Now, we could get to a system as such where I can't just manipulate one equation. I have to think about, I would need these to both get to, what, an 18x, one of them positive, one negative. Or this one, I'd have to get them to, 15y. Now, I'm going to choose the y's because I'm going to be multiplying smaller numbers, a 3 and a 5 versus a 2 and a 9. That's the only reason and they're already opposite signs. So that's why I'm going to take the top one. I'm going to multiply it by 5. And then I'll take the bottom one and I'll multiply it by 3 to get my equivalent equations. So, negative 10x, distributing here, plus 15y equals 5 times 13 is what? Negative 65. Okay. Negative 3 times 9 is 27. X minus 15y equals a negative 9. Now, when I do the addition method, let me go to a different color now. My y's cancel, which is beautiful. And up with a negative 37x equals a negative 74 divided by negative 37, and x equals 2. Now I'm going to take that 2 and I'm going to plug it back into one of my original equations. It doesn't matter which one. I'll take that first one. So negative 2 times 2 plus 3y equals a negative 13. So negative 4 plus 3y equals a negative 13. Add 4, 3y equals a negative 9, divided by 3, y equals a negative 3. So my solution is 2, negative 3. And that is the elimination method, where we eliminate one of the variables. Hope that helps you. Have a great day.